a Casio FX-451, and this one is broken, and it spread garlic mayonnaise all over the vinyl. Have I actually managed to break the ribbon cable? Yeah, this stuff. Beautiful and elegantly done. 8. And I have this gruesome pile of waste plastic. This glorious piece of laser cut acrylic. I have a bag. I appear to have made a bit of a boo-boo. I can immediately see one major cock-up. I get to start again from scratch. Why did it do that? Why isn't it doing that? Okay, well, weird, but it does actually seem to work. So the next thing to do is to do some of the wiring on the calculator PCB. I have mapped the PCB. I've got here pictures of the top and the bottom with all the various wires and pads marked up. And of course there's an issue. The issue in this case is that I was wanting to solder to the top of the board because that's the bit that's exposed when it's mounted on the top of the case. Unfortunately, not all the lines I want are on the top of the PCB. 3 of the keyboard row sense lines only appear on the bottom of the board, which is RX, RY and RZ. They do go through the board because the pins on the chip are on the top, except the wires that do this are underneath the chip where I can't get at them. I don't really feel like soldering wires to the pins of the chip itself because they're really small, so I'm probably going to end up having to solder these wires on the bottom of the board, which I don't really want to do. Apart from anything else, I'll have to remake my mount here to provide more clearance because the wires will take up space underneath the PCB, but that's trivial. And of course, if I'm soldering some of the wires on the bottom of the board, I might as well solder them all for consistency. That way, this thing would be mounted on the case, and you'll see the wires come out the bottom here, go round to the other side of the case, and plug into the keyboard. So I suppose I'll get out the scraper and the fiberglass pencil and get to work. It's all soldered up and ready to go. Weirdly, I had a lot of trouble getting solder to stick to these wires. Once I took the solder mask off, the solder would only really stick to the edge, as you can see here. And I'm wondering if this pale material, which seems to be a slightly different colour to this, might not actually be copper. Is it possible what I'm seeing here is an aluminium rivet through the PCB? Anyway, I was able to take the carbon off these pads and there was real copper underneath, so I soldered them onto those instead. But more importantly, I have a new 3D printer, which means a new pile of 3D printed parts. These ones are modified for the various new designs. And a new piece of laser cut acrylic containing the necessary modifications for the new PCB. It still has that laser cut acrylic smell. Ah, Vox. I also 3D printed these little washers. These are 2mm thick. Combined with the 3mm thickness of the acrylic, that gives me exactly the right amount, according to Cherry's specs, to span the gap between the top of the switches and the position where the sockets should be. So hopefully, once it's all bolted together, all the spacing will be right. and that does look very nice. And here it is, in hopefully its final form, more or less. And I have to say, it looks pretty decent. The keys are nice, they sound okay. The PCB and the screen are nicely visible, and my new design of screen holder with these sides is solid. The rest of it, well, as is now tradition, let me talk about all the things I got wrong. First item, these wires soldered to the PCB are far too short. They're supposed to hook around through these cable guides, these slots, and meet up with the connector on the other side, but they just don't reach. I am going to have to redo all that soldering, which is annoying but not that much work. The difficult bit was scraping the carbon off. Second item, these feet all have angled ends. This is so that they will stand upright on the table and keep the calculator at a nice angle. I forgot to recalculate the lengths and the angles between this chassis and the old chassis, which is a slightly different size. So I'm going to have to do those again. In fact, I've already printed them. Here they are. Second item, the PCB here is slightly too close to the hole, or more accurately, the hole is slightly too close to the PCB, and the old feet don't fit. So the new feet are also thinner. Third item, while I'm generally pleased with how stiff it is in normal typing, the old chassis had a tendency to flex quite a lot. Pushing the key switches in, it does bend in the middle. So I have made an extra foot that will go in here, which will support the middle. But other than that, I think it's looking pretty decent. I will go and make those particular changes. I'll just do it all off camera. So jump cut to the finished item. Here we have some new wires, color coded for my comfort and convenience. Underneath we have some new feet, making the thing good and solid, particularly in the middle where the new foot is. This feels good. Little bit of flex here, but I can live with that. And if I tip the thing up so the camera can see the screen and hold the polarizing filter over here, it even works. So in fact, the polarizing filter, through the magic of careful planning and not accidentally at all, will fit nicely in front of the screen, which is where it's going to live full time. The screen's not easy to see on the camera, but from my angle, it's actually very nice and clear. I've tipped the thing up a bit to make the screen a little more visible, and let me show you that it does actually all seem to function. These two blue wires are the power button, so if I touch them together, that is it resetting. If I pick a couple of row and column wires, which are these green and orange ones, and touch them together, it does a thing. That happens to be the pi button. So that is demonstrating that at least the main logic of the thing still functions, which honestly is very nice to know. Sadly, wiring it up won't be as easy as it should be. The intention was that each of these wires would go through one slot in this cable guide and plug into these connectors. I would trim them off to length and add a crimped-on connector so it would all look neat. Unfortunately, the order in which they plug into the connector here does not at all match the order in which they're coming out of the PCB. So all the wires are going to have to cross over to be in the right place, and I think it's going to look like a bit of a mess. Because I'm an idiot, I forgot to actually write down on the silk screen what all the various wires do. I do have the information, but I'll have to refer back to it in order to figure everything out, which won't be very much fun. And honestly, I'm not really looking forward to it. So much crimping. Here it is, all wired up, crimped and connected together. I did try to test it without putting the pins into the shells, but the pins would all touch each other and short things together and everything was going horribly wrong, so I did it like this. Luckily, it seems that I have most of the keyboard matrix correct. Let me wire it up and show it off in action. Power is something I'm going to have to think about in a moment. For now, it has to go through my bench power supply. Here we go. And the contrast is terrible, but I think it is showing up on camera a little. I'll try and enhance it a bit. So, look, keys work. Power resets everything. I can do maths, and it seems to work. The keys over here more or less work. This is the parenthesis key. However, some keys don't work. Now, I did have to reflow one joint on the PCB to make the power key work, so I suspect this is more of the same. But I have a copy of the keyboard matrix here, so let me just go through and mark off any keys which don't work and see if any patterns show up. I'm pretty sure they will. Well, there seems to be a pattern. Column 8 appears not to be working. So 1, 2, 3, 4, 5, 6, 7, 8. This one. Interesting. Do any of them beep? Yep. Is it connected to the relevant button? No. So I think that, yeah, if I touch the wire, it beeps. If I touch the solder blob, it doesn't. Let me try that again with a bit more zoom. This one. Wire, blob. And in fact, now I'm looking through the camera with small magnification. That does not look like a good joint. So let me crank up the soldering iron and give that another go. And it works. Why is that beeping on both sides? It shouldn't be doing that. Button being pressed? Have I shorted something together? That's very peculiar. It's not working. More than that, none of the other buttons work, so I've successfully broken it. Great. So I think this shows what's happening. Here's the joint that I've just badly reflowed, and here is the one that it shorted to. And you see this track here, I believe that is our track 8. And there's a little bit here where it's touching the track. And voila, it works. That's me pressing the key from the other side. Okay, let's fire it all up and see if it actually works this time. No, it doesn't. Okay, I managed to fail to fix that solder joint, which makes me suspect that there's slightly more to that than just a simple reflow needed. Though it is interesting that of the two problems discovered so far, they both affect the same line. I think it's just coincidence. It might be cursed. Okay, it's properly reflowed now with new solder and everything, and I think that is now in reasonable shape. Time to hook it up again. Woo, it works. Quick check of the other keys. Ah! Great. Okay, the 3 key and M+. That looks like column 4. What else is on column 4? Plus minus. Yep, column 4's dead. That died while I was working on it. So most likely it's another dodgy joint that I managed to disturb. So 1, 2, 3, 4. This is plus minus. Yeah. That one. That's connected to, go through a wire there. That works. Interesting. Now it's working. Was that wire touching something it shouldn't have? So that works. Was that touching the next pin over? That would cause the keyboard decoder to do weird things. So yeah, I think it was. Now it does actually seem to be working. The contrast from where I'm sitting is really good. It's super clear. And I'll work through all the keys. Yep, they're all doing something. The CPU on this thing is so slow that whenever you press a key, you can see the screen flicker slightly, or at least I can see the screen flicker slightly. So I can tell that's actually doing something, even though nothing's appearing on the screen. That's the mode key, by the way. It lets you change number base and so on. And I can feel all the keyboard combinations coming back to me. So that works. AC works, which is nice. The difference between power on here and AC is that power on resets everything, including the modes, which is not actually super brilliant. It also wipes the memory register. I have the chart here. These two are for unit conversion. So I can, for example, type in 1 inch, convert to millimeters, 0.23 millimeters. That's not right. I pressed the right key. Right, no, I didn't. I turned calories to joules. So 1, convert. It's also not right. Hang on, it's this one. Inches to millimeters. 4th down. 1, convert. 1 inch is not that many millimeters. But if I convert millimeters to inches, I get that, which seems to be more correct. Are these flipped? If I put value in memory, recall, yes. Add something to it, recall, yes. Memory in, recall, yes. Swap with memory, yes. Swap registers, yes. So is it just these two? Let me try something else. Fahrenheit to Celsius is 4th down. So 0 Fahrenheit in Celsius is 32. That is correct. So 1 inch in millimeters is not that. But if Fahrenheit worked, 32 centigrade, convert the other way to Fahrenheit. No, wait. No, 32 Fahrenheit converted to centigrade is... No, that's converted 32 centigrade to Fahrenheit. I think I've got these flipped in my chart, which means that the PCB is wrong. So I can fix it by modifying the PCB or by changing the labels on the keys. It will mean that it'll look a little odd, but it is much easier. It is these two keys here. This is the common connection for the row. The column wires that the two buttons are connected to are tucked away inside and will be on the other side of the PCB. I can't even see the... Oh, there, look. That minuscule wire and that one. I made the tracks on this PCB way too narrow. It's just the standard KiCad settings, but yeah, I should have changed that. Yeah, I think this is going to be nightmarish to fix, so I am just going to change the labels on the keys, which is the next job. And after a surprising amount of work, it is now done. I am not super thrilled with the way it came out. I chose the Papercraft method simply because it was possible. I can print these out on my printer, cut them up and stick them under the keycaps, and then it works. The styling is not brilliant. I had to design all these myself in Solvespace, but it should at least function. The original Casio color scheme was rather nice, but is not appropriate for these white keycaps. I do have a color printer, but I don't think that inkjet color is going to look better than the simple black and white. It would be really cool to get some custom keycaps made using the right designs and the right fonts. But getting custom keycaps made is surprisingly expensive, so I'm just not gonna. At least like this, it works. Or at least it would if I hooked some power up to it. And that brings me to another thing. Rather embarrassingly, that solar panel that I put so much effort into getting out in one piece has vanished. It's quite small. I can only assume I accidentally threw it away at some point. So I'm going to have to come up with some other way to power the thing. It runs off 1.5 volts, so the simplest option is to just use a single AA battery. It'd be nice to run it off a button cell. I even got as far as 3D printing a button cell holder before I remembered that these things are 3 volts, not 1.5. And while this may work off 3 volts, I don't want to try it, because this is the only one I have, and I put quite a lot of work into getting this far, so I'm just going to use 1.5 volts. Annoyingly, if I'd known I was going to need to use a battery on this, I would not have wired up the reset button, because the power on off would have done that for me. And the problem with reset is that it resets everything. It does a power on restart. It wipes the memory, it wipes your modes, the lot. This is different in functionality to the calculator I had, which had battery backup, where pressing the on button would just wake it up. But too late now, so let me go and rig something up. I found something. In the back of a junk drawer, there are these 2 packets of unused 1.5 volt button cells, which should be ideal for running the calculator off. These don't provide a lot of power, they're about 30 milliamp hours each, but the calculator consumes almost nothing. So I went ahead and I made this adorable little 3D printed button cell holder, and it does have a battery in it. Sadly, it was only after actually making it that I got around to measuring the voltage. 1.06 volts should be 1.5. All these batteries are dead. Also, I did check, and 1 volt is not enough to run the calculator. I went back to my junk drawer. I found this, which is a packet of 1.5 volt button cells. These ones I actually used. There were 2 left. And in this slightly less adorable 3D printed button cell holder is one of those batteries. And if I measure it, I get 1.5 volts, which is the right voltage to run the calculator on. So the way this thing works is that it's 2 symmetrical 3D printed shells held together with an oversized M4 bolt. And by the way, the fact that the shells don't meet up here is deliberate. That applies pressure on the battery to hold the 2 copper wires firmly against the sides. It does actually seem to work. The M4 bolt is far too big for this, but was very deliberately chosen because it's the same size as these bolts here, which are used to fasten the PCB to the acrylic shell. This means that for testing purposes, I can temporarily attach this directly here and wire up the wires very easily and see if it works. I set up a camera to get better pictures of the screen because I was going to do a demo of all the nice features of this calculator, probably involving a joke about witnessing the power of my fully functional, etc. Unfortunately, it's not. There's a problem. Let me demonstrate. Let's type in a number, like so, and add 1 to it. That's not right. Let's try subtracting 1 from it. That's right. Multiply by 2? Not right. Divide by 2? Also not right. So what's going on here is that the keyboard matrix is wrong, and these 4 operators are in the wrong places. So let me try and figure out what does what. So I think this one is multiply. So if I do 2 times 3, that gives me 6. Yes, that is multiply. What is divide? 2. That's plus. So we know this one is multiply. And we know this one is plus. So what is this? 2. That's divide. Put that here. What's this one? That is minus. Okay, so minus is in the right place. The others are not. So now we should be able to do 2 plus 3 is 5. 2 times 3 is 6. 2 divided by 3 is 2/3. 2 minus 3 is minus 1. Okay. So it's now working, but that's not ideal. So what's wrong? Here is my trusty chart of the keyboard matrix. And I know that multiply is swapped with plus. Very dodgy arrows there. Plus is swapped with divide. Wait, hang on. So that's... And divide is now multiply. So this suggests that these 3 column lines are just wired up incorrectly. However, all the other keys using these column lines work right. So I can do 4, 5, 6. That worked. And I verified that all the other keys work. So it's just these 3 keys. That means it's not a problem with the column lines in general. It is specifically the wiring of these keys here. Thankfully, thanks to the power of buying 5 of them, I have a number of spare PCBs. So we can follow the wiring here. These 3 keys are these 3 here, which are these 3 here. Is this actually fixable, I wonder? After a certain amount of confusion trying to figure out what was going on, I have in fact discovered it's a bit worse than that. The labels that I wrote on the PCB are also wrong, but in a different way. So this is the correct layout for the calculator, with multiply and divide on the top row and add and subtract on the bottom row. But what I've put here is plus and multiply in the top row and subtract and divide on the bottom row. But the layout that's actually on the PCB has got plus and multiply in the top row and divide and subtract on the bottom row, which is the same as the PCB, but these 2 are swapped. So multiply has become add. Divide has become multiply. And divide has become plus. So with the help of a printout of the back of the PCB with KiCad, flipped so it looks right looking at the bottom of the PCB, here are our 3 terminals, which is this one, and this one. This one is a leaf. There's a track leading to it, which goes nowhere else. However, these 2 are not leaves. They have a track leading to them and then away somewhere else. So, in order to rewire this, I first have to cut the tracks to the pads. Then I have to bodge together the cut tracks. And then I have to bodge wires from the appropriate place back to the pads in the right order. And these tracks are far too thin. I think I do want to try and fix this because this is annoying. So Let me disassemble the calculator and get the PCB out, and then let's have a look at the bottom of that relative to this unpopulated PCB. Or actually, I don't need to disassemble it, which is nice because that would involve removing all the key switches again, because just turning the thing upside down makes it pretty easy to work on. So we want this track, these two tracks, and these two tracks. The bodge wires need to run from, not necessarily from the tracks themselves. It'd be much easier to solder to these terminals. So these two tracks here go from here to there, I believe. And in fact, before I do anything else, let's just unplug these two. The piece of Kaptan tape was an attempt to keep these connectors reasonably in order, because after all, the calculator is still turned on because that battery is hardwired. So I've got the beeper. This goes to here, which goes to here. No, here. All right, and this one, I think this is a bridge here. So this goes to somewhere up here. No, that one. Those would be some really annoyingly long bodge wires. However, I think I can find alternates. Yeah, so, well, that's clearly here. Are there any other closer sixes? No, because this is the route that goes to this entire side of the board. There is only one wire there. Yeah, I think this is doable. It's just annoying. So let's cut this one. That should be the easiest. So, is that connected to anything? Looking at my chart, that is E6. So I need another 6. This one. Not connected. Just, yeah. So, that one is cut. Next, let's cut these two. That is E7. You can't see the things I'm probing because it's too far away, but yes, that is also cut. But it's not cut this way, so need to cut the other route. I should get an engraving tool. They're ideal for cutting tracks. That's cut. Okay, and the last one is this one. We want to cut these two wires. And that connected here? No. And this should not be connected to any of these on the left-hand side. Okay, so that's done. I've now completely wrecked my calculator. So the next job is to solder in the bodge wires to make the other keys, except these 3, work. Okay, let's see what works then. No. No. Have I desoldered the wrong switch? I think I have. Yeah. Okay, well, let's try these. That one works. That one works. That one works. That works. Great. Actually, I think I'm confusing myself by having these switches in the wrong position, so let's fix that. Divide goes here. Multiply goes here. Subtract goes here. And addition goes here. All right. So that's wrong. These two are disconnected. Yes, I think I have managed to confuse myself by marking the wrong pads on this chart. I'm going to have to reconnect and subtract track and disconnect additions. That's these two, and the track for this switch goes up this way. Hopefully it should just be a matter of doing this. No. The track is just too thin, so let's bodge wire it. Okay, 2 minus 3. Wait a minute. Didn't divide not work before? I have reconnected the wrong track. Oh dear, I meant to do this one. Okay. That is connected to one of these. That one. Okay. And this is now not connected. Right. Oh, and I forgot to unplug it, so I was doing all that live. Doesn't work, doesn't work, doesn't work, does work. 2 minus 3 is minus 1. Okay. So I've successfully disconnected these switches. Oh, and I should check these. Yeah, they all work. So now it's just a matter of flipping this so it's the right way up. Like so. Reconnecting the column wires in the right order. It is the next day, and once again I need to remind myself not to work on this stuff while tired, because not only did I screw up the soldering repeatedly, but I also screwed up this diagram because I apparently wrote down that the divide key has been mapped to both plus and multiply at the same time, which makes no sense. So we're going to have to do this by trial and error and just hook some stuff up and see what happens. So let's cut off a bit of wire and solder it up and then plug it in and see what it does. Let's just move this a little out of the way. This is all going to get hot glued down later. It doesn't flap around in the breeze. Okay. And now we turn it over, press the key and see what it does. All right. Is it wired up? Yes, it does a thing. What kind of thing does it do? Holy cow! Purely by chance, I managed to pick the right one. Excellent. That is now a divide key. So we should have these two not doing anything, and these two are correct. 2 minus 3 is minus 1. 2 divided by 3 is 0.6. So let me just resolder that to be a bit tidier. Try not to burn myself. And done. Okay. There now being only two options left, which is this one and this one. We know that when these were connected up to the original tracks, they were wrong, therefore they must be just the other way round. We need to find a source for what that was. This track goes up to here, but there is actually a wire on that. So we can put a wire from there to there. It's not a proper electrical project if you don't injure yourself at least once. I'm more concerned about injuring the board by touching the soldering iron to some of the large amount of low temperature plastic. Okay, that should be in place. And then while we're at it, let's do the other one, which is this one. This used to be connected to here, which is now this pad here. That's not connected to anything on the other side other than, one of these little pads that I can't really do anything with. So let's just hang on. Actually, I think this to me needs to be connected to what this used to be. So that's this contact here, which I can also find there. But tell you what, let's just check that one to see if it works first. So 2, this one, 3 is 5. Okay, that is wired up correctly. So we now have 2 minus 3, 2 divided by 3, 2 times 3 doesn't work, and 2 plus 3 is 5, or at least 25. And check these ones. They all do something. Okay, last connection. So we need to connect to this what this used to be connected to, which is this pad, which I should be able to get to from here. Yep. I just want to avoid soldering more than one wire to a pad, because that way wires will fall off and it's like annoying and stuff. And hopefully done. So turn over and let's see what it does. Oh yeah, let's put that divide key back on. Okay, multiply 6.6, 5, minus 1. Excellent. These are now all in, I hope, the right place. And here is the old calculator. Multiply, subtract, plus, and divide. Good. So there's only really one thing left to do, which is to figure out a permanent home for the battery here. This little button cell has been running the calculator for most of a week now. This has all taken quite a lot of wall clock time. And let me just try and measure the voltage. See if it's changed at all. It was 1.50. Okay, it's dropped a little. So it's clearly perfectly capable of running the calculator for an extended period of time. But I think I do want to put a switch in. And the obvious place to put that switch is here, the power button. Unfortunately, well, Cherry did make toggle switches. That is, you press them once and it latches on. You press them again and it switches off again. These are now impossible to find. So, while I am scouring eBay looking for one of those, let us instead fake it with this 3D printed adapter, which will go in this hole and allow me to attach a normal toggle switch to it. So the switch goes in there, and then this will go in like this. and that will be my power switch. There's actually not quite enough space for the contacts sticking out the bottom of the switch, so I'm going to have to trim those a little. Like this. So now this will go in here, and the bottom should be completely flush. However, before I attach it, I do need to solder some wires on. And that's now in place. Good. Not brilliantly solidly, actually. So the next thing is to solder these wires. Let's loop that back over here to the switch terminals, because we're not using the switch terminals anymore. I'm going to want to change the wiring somewhat. This button originally connected to the power button on the calculator itself. Pressing the button would cause the calculator to reset. But now we've repurposed it as a switch. So this now needs to be in line with the power supply, which I have now disconnected because this is doing something else. The wires to this are actually routed to these two blue wires here, which go to the reset button on the board. So those wires need to be moved. Okay. So black wire goes to the battery negative terminal, blue wire goes to the battery positive terminal. So it's all reassembled and we're looking at the bottom of the board. So let's plug it up again. Like so. And I have moved the battery to the other side of the board and put it here. It's still slightly bodged together, but that is because at some point I do want to replace the battery with a 1.5 volt AA, but that will wait until I have a part arriving, so this is kind of bodged together for now. But all we need to do is solder it up to the right wires. This is the positive side of the battery, in fact. Positive side of the battery. So the blue wire wants to connect there. I don't want to heat this copper wire too much because the other end's attached to a 3D printed thing which will melt. Okay, one terrible joint later, and the black wire connects to the other terminal, which is here. And we should be ready to go. Typical. It works, but the switch is wired up the wrong way around. Okay, that is firmer and the right way around, which is good. Okay, one final touch is a few dabs of hot glue to just hold everything together neatly. And so, finally, behold the power of this fully... the moment's gone. Let me just give you the tour. So let's power it on and see what we get. And what we get is a 0. This is your classic LCD display with 7-segment digits and a few status indicators at the top. The bottom row is for displaying numbers and a few other things under rare circumstances. The top row has fixed purpose indicators which will light up to tell you various things are happening. The screen will display 10 digits plus 2 for the exponent. That means times 10 to the 32. Internally, it works largely in floating point with fairly intelligent handling of the number of decimal places displayed. But you can override this by doing, if I can remember how, mode 8, 6, there we go. That is now using scientific notation. You can see the little psi thing has lit up, darked up, appeared. It is now showing 6 digits of precision plus the exponent all the time. And you can change this to anything you like. Whoops, that just stick. And should just stick the thing into octal. I'll talk about that later. Mode 8, 1. 1 digit of precision, 2 digits, 3 digits, and so on. Mode 9 puts it back into default mode. You can also tell it to display things in engineering numbers, which is similar to scientific notation, but if I do this, 0.001, and then press eng up here, it rounds the exponent up or down to the next multiple of 3. So that is saying it's 1 milli, or 1000 micro, or that many nano, and you can use this one to go in the other direction. So here we have 0.001 with no multiplier, etc., etc. The thing is designed so that nearly every function is approximately 2 key presses away. So if I demonstrate some basic arithmetic, like say that, plus 1, you never have to refer to the previous answer. Everything you do just builds on what is already there. It does support limited operator precedence. So if I do 1 plus 2 times 3, it evaluates the 2 times 3 first and adds the 1. You can override this using the parentheses buttons. So 1 plus 2, close parenthesis, times 3, which gives 9, the other answer. For basic arithmetic, you get the usual plus, minus, multiply, and divide. For non-basic stuff, we move over here. We have single key access to stuff like 1 over x, square, square root, cube root, factorial, and of course, if you try to work with a number above about 10 to the 99, it overflows and you just get that error. On underflow, by the way, it just rounds down to 0. You also get your standard trigonometry functions, sine, cos, tan, and their inverses. You get to switch whether the units are in degrees, which is the deg thing there, or, remember the right buttons, radians or gradians, which I have never seen a use for. A gradian is a unit where, if I remember correctly, there are 100 steps to a right angle. So if I do 50 sine, yeah, that's the same thing we got when we tried to take the sine of 45 degrees. So I can put this back to degrees, inverse sine, and we're back to 45. It also supports the hyperbolic trigonometry by using shifted versions, and I have no idea what these are. I've never worked with hyperbolic trigonometry, so yeah, they work. These 2 buttons here are interesting because they will allow you to convert between decimal degrees and the degrees, minutes, and seconds representation. Oops, wrong way around, that one. So that is telling me that the 2.5 I entered is 2 degrees, 30 minutes, 0 seconds. If I do 3.25, 3 degrees, 15 minutes, 0 seconds. This is the traditional base 60 representation of degrees. And the deg button allows you to enter these. So if you do 3, deg 15, deg 0, I think I missed the last deg of that. I don't really use this. Deg 0, deg, there we go, 3.25 degrees, which is 3 degrees 15 minutes. Other useful stuff you can do: base 10 logarithms, 10 to the x, natural logarithms, e to the x, all single press. These two are binary operators for doing arbitrary powers, so I can do 2 to the power of 6 is 64. This allows you to do arbitrary roots, so that, the sixth root of that is 2. You notice it's not very quick at doing that. I actually think I'm undervolting it rather. There is one last remaining operator, which is r to p and p to r. These convert from radial to polar coordinates, rectangular to polar coordinates and back again. And these take 2 parameters as a standard binary operator, but they also return 2 parameters. And that is where xy comes in. There are actually 2 registers visible. There is the current one, that is the thing that's on the screen, that is x. And then when you do an operation, the operation pushes the old value of x into y. X is 32 and y is 65. And xy here will swap between them. Sorry, 56. So this is actually quite useful for doing inverted operations. For example, if I have a value and I want to subtract that from another value, for example, I want to subtract 6 from 35, but 6 is the thing that I currently have because that's the result for previous computation. I can do minus 35, do that again, 6 minus 35, swap x and y, and when I press equals, it does 35 minus 6 to get 29. R to P and P to R use this to return the results. So a rectangular coordinate, let's say 5, 5, gives me a radius of 7 and an angle of 45. And likewise, I can do 0.7, polar to rectangular, 45, and that gives me x of about 0.5. I did that wrong. It should be 7. 45, there we go. There we go, about 5, and also about 5 in the other ordinate. It's also got some fun features for doing repeated calculations. So if I want to, for example, repeatedly add 5 to numbers, I do 5 plus plus. Notice the k has appeared. And now I can enter numbers 60, 65. This preserves the value in y. 98, 103, 1, 6, and so on, which is very handy for doing certain operations like, working down a list of figures, the kind of thing these days you use a spreadsheet for. There is no delete key. If you make a mistake when typing, you can press C, which just clears the X register, and you start typing in again. I have seen versions of these with a delete key. There was a period where you could get clone calculators that had basically the same functionality except not as well laid out that did have them, and it's something I slightly miss from this. But honestly, if you're using this thing without really looking at it and you type in a number and you realize you made a mistake, you can just press C to clear everything and type it in again without having to look to see what mistake you've made, which is potentially nice. It does number bases. Currently it's in decimal. Decimal is the only mode that actually supports fractional numbers, but I can set it to octal, which does base 8 arithmetic. You get all the usual arithmetic operations. Oh yeah, of course I can't divide that by 9. There is no 9 in base 8, and so on. No fractional numbers, of course. Integers are all you get for this. And when it's in a integer base, most of the functions down here don't work. So, you can't do sine and cos of an octal number. But you can do logical operations on them, which is the secondary function for all of these. So neg negates it, which is different from plus minus, which no longer works. Other bases include binary, so let me OR that with 10, like so. We can XOR it with 1, which toggles that bit, and XNOR, which is a little exotic, which I've never used. And of course, I can always convert back to decimal at any point, or to any of the other bases. The third one, of course, is hexadecimal, and that's where these 6 keys come in. So from here, if we not 0, we can see that we have 32 bits of precision. With rollover to 0, if we negate 1, we get that, indicating 2's complement. If you work with computers like I do, this is really handy. So anyway, back to decimal. Other features. It has a lot of built-in physical constants, which are these things here. I used these a lot when I was doing A-level physics. So we've got the charge on the electron, /h, whatever that is, gravitational constant, little g on Earth, though despite the number of decimal places, do remember that little g is not a fundamental constant, and in fact it varies depending where you are on the planet, and so on. And of course, we do have pi. Wouldn't be much use without it. We also have ran, which gives you a small random number. I have barely used this. And round here rounds off numbers in an obscure fashion that I never quite got my head around. I've already talked about unit conversion. Here is the full list. I did turn out to have made a mistake in the labels, so I've reprinted some of them. It includes simple unit conversions where you just multiply or divide by a constant, as well as a more complicated one where you have to also add or subtract a bias. So, convert from 0 centigrade to Fahrenheit gives you 32. So we've got charging the electron here. In kilograms, let's put that into pounds. I want to know what that is in ounces, but I can't remember how many ounces to a pound there are. So we put it back into kilograms. Divide by 1,000 to get the wrong thing. I actually want to multiply by 1e6 to give me the unit in grams, and then I can convert this to ounces. I'm sure that's useful somewhere. It supports converting gallons to litres, but it is, of course, a US gallon, so not very much use to me. Although I live in Switzerland now, I just don't use gallons for anything. The one interesting omission is that it doesn't allow you to convert between miles and kilometres. Given that there are 2 here for doing air pressure, that seems weird. Okay, further features. It has a single user memory register, which is M. I can put a number into it by pressing the M in button. And M shows up to indicate that the value of the M register is non-zero. And I can recall it. I can add to it. I can also subtract from it. giving me 55. Useful for summing stuff. If the value goes to 0, so if I press MR, press that to negate M+, then the M thing goes away. That's useful for financial stuff, and in fact it has an additional feature for that. If I put in a value and I want to get 50% of it, I can either do multiply by 0.5, or I can do 15 times 50%, and that does the scaling automatically. Again, this is something I've almost never used. I don't do that kind of arithmetic. When I do need to take percentages, they're usually expressed as a fraction anyway, so I would work with 0.5 rather than 50. There's a whole bunch of stuff over here. This is the statistics unit, which I have again very rarely used, and I can put it into statistics mode by doing this, and SD shows up. I can now enter values into it. It's not remembering them, it doesn't have enough memory for that, but it is keeping track of things like the number of values. So I've entered 6 values, the sum squared, and this lets it do useful things like calculate the mean, as well as the standard deviation, which I believe are these 2 buttons, but I've never done anything with that, so I don't know how that works. You can remove values if you make a mistake. So if I add a 99 and didn't mean to, I can do 99 again and press del. Let me just get n to prove that. Currently have 7 numbers. Let's delete 1. We have 6 numbers. And the sum, etc., will all be adjusted correspondingly. So that's back to the previous value we had. And this is all held separately to the M register, so that if you really feel like it, you can track 2 running totals at once, one in M and one in the statistics unit. But of course, when you're in statistics mode, you don't get the other functions of these keys. And that is very nearly all the features. Let me put that back into normal mode. There is one other thing that is super cool, which is that this does not just support floating point number representation, but it also supports fractions. So I can do a half by doing 1, 2 like this. That is displaying a half in as best it can with this display. I can divide it by 3, and it turns into a sixth. I can add 9 and 1/6. I can divide it by 8, 1 and 7/48. It attempts to normalize the fraction as best it can, but when you're dealing with something like this, it clearly can't. If you try to do anything with it that involves a floating point number, like add 0.2, it of course coerces it back to a floating point number. The same applies with everything over here. But it's still surprisingly useful. You do only get 3 digits for the denominator, but that is good enough. And you see here, that will put the denominator out of range, so it coerces it into a floating point number again. And that is all the features. I really like this. It's not as flexible as a reverse Polish calculator, but I think is way easier to use. And so there you have it. It's done. Am I pleased with it? It's okay. If I was doing it again, I think I would design it differently. I knew that parts of it would be exposed to the outside world like this PCB, so I went for clear acrylic in order to try and accentuate the skeletal nature of the design. This was deliberate. However, I'd forgotten just how well acrylic picks up fingerprints. I think that if I were to do more work on this, I would produce a different acrylic sheet, possibly out of something like white acrylic, put a slot here and have the PCB on the underside with the screen sticking through. There isn't just enough slack in the ribbon cable to allow that. That would keep all the works underneath, which would make wiring it up much easier. There would be a space here that's unused, but that would be a perfect place to put a new solar panel if I get one. The keys I don't really like very much, but they're functional. The flat top isn't quite what I wanted. I picked cheap clone cherry linears for this. I might have been better off with tactile switches. I might get a batch of cheap clone tactiles and replace it and see what happens. I was going to try and source a clicky toggle switch for the power, but this is growing on me. So I think I might keep that. And the tiny little battery is a little regrettable. There's enough space up here that I could put a AA battery holder in. A AA on this thing is total overkill. The battery would self-discharge before the calculator could possibly run it down. But AA's are easy to recharge, and I wouldn't need to worry about power. I could do stuff like put a power LED on so that it's slightly more obvious when I accidentally leave it turned on. Am I pleased with this? Yes, actually. I have been wanting a full-size desk calculator with this functionality since I was in school, which is 35 years? Yikes, I feel old. But now I finally have one. It looks like I can get a custom keycap set for about $80, so I'm still thinking about that one. Given how often I've had to reprint segments of this due to making mistakes, I suspect that I don't want to hurry into getting a set of custom keycaps made. But anyway, I am going to call this finished now, and this is going onto my main desk where I will use it for stuff. This will be great because it will free up my workbench. This has taken a really long time of actual wall clock time. The directory in which all this video is going in is labeled July. But once it's edited down, the video will not be 5 months long, and I hope was interesting and or enjoyable. So I'm going to leave it here. As always, I hope you like this video, and please let me know what you think in the comments.